Hi everyone, today we're going to be starting lesson 1.3 with lesson 1.3a, part A. We're going to classify real numbers. Our objective today is to classify rational and irrational numbers. So I'm going to go through this part of the video, and as I say certain words, I want you to take your notes in this section of your note page. So let's talk about numbers. When you first started learning numbers in elementary school, the first thing you learned were your natural numbers. You would get some blocks and you would start counting them, and you might say 1, 2, 3, 4, 5. Those are all your natural numbers. You could keep going forever. Probably couldn't count that high when you were little, but in theory, you could keep going. Then, after your natural numbers, come your whole numbers. Well, what's the difference between a natural number and a whole number? Well, the only difference is the addition of the zero. When you first count things, you don't start at 0, 1, 2, 3. No, you just count 1, 2, 3, 4. But yeah, you get the idea of zero added later, and that is a whole number. So a whole number includes 0 plus all of your natural numbers. Okay, as you moved on, especially like last year, we added the concepts of integers. Well, what are integers? Integers include all of our natural numbers, 1, 2, 3, 4, etc., and 0, and then the opposites of all of these natural numbers. So the opposite of 1, we would have -1, -2, -3, -4, etc. So the definition of integers is our positive and negative whole numbers and 0. Next, we have our rational numbers. You'll notice you see the word ratio right inside the word rational. That's because these numbers can be written as a fraction. All of our natural numbers could be written as a fraction, 1 over 1, 2 over 1, 3 over 1. Our negative numbers could also be written, our integers could also be written as fractions. But we have other numbers that can be written as fractions, like 1/3, -2/3. All of these can be written as fractions. Let's see, we have 14/3 even. That would be a fraction. Anything that can be written as a fraction would be a rational number. Now, do rational numbers always have to be written in fraction form? No. 3.2 is a rational number. That's 3 2/10. I could write 3 2/10 as a fraction, so therefore it is a rational number. -1.5. I could write as a fraction. 0.6 repeating. I could write that as a fraction. That is 2/3 actually. So if I can write it as a fraction with integer, numerator, and denominator, it will be a rational number. Lastly, we have the concept of real numbers. Real numbers includes all of these natural numbers, our whole numbers, our integers, our rational numbers, but it also includes irrational numbers. Irrational numbers are the numbers that don't repeat and don't terminate. Like this one would terminate. 3.2, that terminates, it ends. 0.66666, that repeats. I cannot write our irrational numbers as numbers that have a numerator and denominator that are whole numbers. So some of our irrational numbers might be things like the square root of 2. square root of 5. If I put those in my calculator, you will see that they go on forever and they do not repeat. Another common one is pi. That's at 3.14159 dot dot dot. It keeps going on forever and it doesn't repeat. So if you see a decimal that has a pattern, it goes on and on and on and on, and you don't see a pattern, you can't predict what comes next. So if you see something like this and then it puts a dot dot dot, you can't say, gee, what comes next? It could be a 2, but it could be a 5, it could be a 6, it could be anything, a 0. If you can't predict what's going to come next, then you're going to be probably dealing with an irrational number, which is part of the real number system, but it's not rational. So let's see how you did at filling in your notes. Oops, I have a bunch of stuff there. I should have cleared my screen. Okay, so for natural numbers, did you get counting numbers? Might have written counting numbers, or you could have just written, 1, 2, 3, 4, etc. So writing with the mouse is not fun. 1, 2, 3, dot, dot, dot. Whole numbers are just your counting numbers, your natural numbers, plus 0. So it's this, all of your counting numbers, plus 0. Your integers are going to be your whole numbers, their opposites, and 0. Just giving examples. And they'll keep going forever this way and forever this way. And my rational numbers, they're my fractions. They're terminating and repeating decimals. Terminating decimals and repeating decimals can all be written as fractions. So if a number can be written as a fraction, it's going to be a rational number. And lastly, we have our irrational numbers, numbers that cannot be written as a fraction. They don't terminate and they don't repeat. Let's practice. And I gotta clear the screen. You have the sheet in your notes. I'm going to give you a bunch of different numbers and you're going to practice sorting them. I'm just going to throw them all out there for now, and then we'll go back and we'll sort them together. So I'll have these here, and then I'll give you a little bit of time to decide. You might want to hit pause on your video. Okay, let's look at this. 22/7. Is it written as a fraction? Yeah, so, oops. Don't know where that went. I guess I can't slide them there. I thought I could. Negative 80, square root of 81. Square root of 81 is 9. It is a rational number. Square root of 9/16. This would be 3/4. It is a rational number. Square root of 1/4. This would be 1/2. Rational number. 22/7. Written as a fraction. It's a rational number. 0.575757 gave the dot dot dot, but you can predict that a 5 is going to come next, followed by a 7. If you can predict that, you know it's a rational number. Square root of 36 is 6. 0.17, that's a terminating decimal, so it is rational. 4 times the square root of 9, well, the square root of 9 is 3, so that's rational. 4 times 3, this just equals 12. Cubed root of 27, well, what number times itself 3 times equals 27? 3 times 3 times 3, that is rational. 1/2 the square root of 64, the square root of 64 is 8, half of 8 is 4, that is a rational number. Cubed root of 8, 2 times 2 times 2 is 8, so that is rational. -3 1/5, that is a mixed number, rational. Square root of 144 over 3, square root of 144 is 12, so it is rational. Now let's look at these irrational. Square root of 17, the 17 is not a perfect square, so it will be an irrational number. 68, not a perfect square. 64 is, but 68 is not. Pi, we talked about that already. Square root of 11 is irrational because it's not a perfect square. Therefore, if I add something to it, it's still not going to be a perfect square. Again, if I multiply pi times anything, if I take an irrational number and I add to it or multiply by it, it will stay irrational. Square root of 50, not a rational number. Square root of 82, 82 is not a perfect square, therefore it's irrational. Pi again, if I take an irrational number and add 7 to it, it's still irrational. Square root of 15, also irrational. Square root of 16 is a rational number, but 15 is not. It's not a perfect square. We had a question, if you had a question like this on your MCA, the question would be, which one results in a rational number? Well, if I take an irrational number and I add to it, it's going to stay irrational. So square root of 1.5 is irrational. Square root of 12 is irrational. Square root of 3/4 is irrational. Square root of 25 is just 5. It is a rational number. So 25 divided by 5 will give you 5. This would be your rational number. That is it, I believe. Oh, nope, we still have another practice. Which following is irrational? Well, here's a terminating decimal. That's rational. This is not a perfect square. 64 is a perfect square, but 66 is not. So this is irrational. But let's check the rest. Square root of 9 is 3. That's rational. And 3/11 can be written as a fraction, so it's rational. Which one's irrational? Square root of 49 is 7. Square root of 25 is 5. 1.7 can be written as a fraction. It is square root of 39. And again, is this rational, irrational, both, or neither? Well, you can't be both rational and irrational. And we're not dealing with imaginary numbers, so we're either going to be rational or irrational in 8th grade. So my question is, can you tell what's going to come next? If you have 0.181818, pretty sure we're going to be followed by a 1 and then an 8. So this number is rational. We can predict what's coming next. It's a repeating decimal. Does a set contain rational numbers, irrational numbers, or both? Now these ones we can't have a both because we have a list. 8.35, that's rational. 8 3/3500, I can certainly write that as a fraction. Square root of 64 is 8, so that's rational. 41 divided by 5, this is written as a fraction. If I can write it as a fraction, it is rational. And 35 is a rational number. These are all rational numbers. Which is irrational. Well, if I take an irrational, which one's rational? I have to read correctly. If I take an irrational number and multiply it by 3, it is still irrational. If I take an irrational number and add 5, it is still irrational. If I take an irrational number and divide it by 4, it will still be irrational. But square root of 16 is rational, so I can multiply that by 2 and it is rational. So D would be the correct answer. Which one here is irrational? Well, the square root of 4 is 2, so that one's rational. This is a repeating decimal. It's going to keep going 3, 3, 3, 3, 3. That's rational. A fraction written with 2 integers, rational. 74, not a perfect square. This is irrational. Which number is irrational when multiplied by 5? Well, if it's rational to start with and I multiply it by 5, it is still going to be rational. 1/3 is rational. Square root of 16 is rational. That's 4. 4.444444, that's a repeating decimal. I believe if there's a dot, 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 they didn't put a dot, 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 so it looks like a terminating decimal to me. Either way, that would be rational. Square root of 3 is irrational. So if I multiply an irrational number by an integer, it's going to stay irrational. I don't know why it went to Quizlet, but it wants to for some reason. So we will look at our last example here, and then we'll call it done for the time being. Which number is rational when divided by 3? Well, only number that will be rational when divided by 3 is a number that's rational before. And looking at this, square root of 10 is irrational. Square root of 65 is irrational. Pi is irrational. So if I divide any of those by 3, they're still going to be irrational. 1/3 is rational. If I divide 1/3 by 3, I will get 1/9. That's a rational number. That's it. Thanks for watching.